This is the AP Statistics Quideo number 2 basic question. Do heavier people burn more energy? Metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. We have data on the lean body mass and resting metabolic rate for 12 women who are subjects in a study of dieting. Lean body mass, given in kilograms, is a person's weight leaving out all fat. Metabolic rate is measured in calories burned per 24 hours. The researchers believe that lean body mass is an important influence on metabolic rate. Here we have the data for the study, with mass in kilograms being on top and the metabolic rate on the bottom. A woman with a body mass of 36.1 kilograms has a metabolic rate of 995 calories burned per day. 54.6 kilograms, 1,425 calories burned per day. 48.5 kilograms, 1,296 calories burned. 42, 1,418 calories. 50.6, 1,502 calories. 42, 1,256 calories. 40.3, 1,189 calories. 33.1, 913 calories burned. 42.4, 1,124 calories. 34.5, 1,052 calories, 51.1, 1,347 calories, and 41.2, 1,204 calories. Now, let's put the data in order of mass in kilograms from least to greatest to better understand the data. A woman with a body mass of 33.1 kilograms has a metabolic rate of 913 calories burned per hour. 34.5 kilograms, 1,052 calories. 36.1 kilograms, 995 calories. 40.3 kilograms, 1,189 calories. 41.2, 1,204 calories. 42, 1,256 calories. 42 again, 1,418 calories. 42.4 kilograms, 1,124 calories. 48.5 kilograms, 1,396 calories. 50.6, 1,502 calories. 51.1, 1,347 calories, and 54.6, 1,425 calories. According to the data set, it appears that the higher the body mass, the more calories are burned in 24 hours. However, there could be a few exceptions to this claim, such as someone not exercising as much as the others, or someone being very lazy one day and not wanting to exercise at all. Now, let's rearrange the data in order of metabolic rate, calories burned per 24 hours from least to greatest. This time, rate is on the top and mass is on the bottom. 913 calories burned per hour equals 33.1 kilograms. 995 equals 36.1 kilograms. 1,052 equals 34.5 kilograms. 1,124 equals 42.4 kilograms. 1189, 40.3 kilograms. 1,204 equals 41.2 kilograms. 1,256 equals 42 kilograms. 1,347 equals 51.1 kilograms. 1,396 equals 48.5 kilograms. 1,418 equals 42 kilograms. 1,425 equals 54.6 kilograms, and 1,502 equals 50.6 kilograms. At the beginning of this data set, it appears that as the rate increases, so does mass. But with the rest of the data points, the graph becomes less positive and will appear approximately normal. So here is a scatter plot of the data of mass versus metabolic rate. Here is the scatter plot of the graph of mass versus metabolic rate. For the y value, I used metabolic rate. The graph starts at 0, but there is a break in the graph, and it goes to 900 and continues by 50 until it gets to 1600. And with mass in kilograms, or the x value, it starts at 0 again, but there's a break in the graph, and it starts up again at 30 and goes by 3 all the way up until 60. Studying the graph, it appears that the majority of the points are close to the line of best fit, except for 2 that are very far away from the line. The direction of the relationship is left to right, indicating a positive correlation. The form appears to be normal. The higher the x, the higher the y. The strength of this relationship is a strong positive correlation because as the mass in kilograms gets higher, so does the metabolic rate. And that concludes the basic question portion of the Quideo number 2. Now, on to the advanced question. 6-minute walk test in children and adolescents. The data in the accompanying table are from the paper 6-minute walk test in children and adolescents. Boys completed a test that measures the distance the subject can walk on a flat, hard surface in 6 minutes. For each age group shown in the table, the median distance walked by the boys in that age group is given. For the age group of 3 to 5, the representative age is 4, and their median 6-minute walk distance in meters is 544.3. For the age group of 6 to 8, the representative age is 7, and the median 6-minute walk distance in meters is 584. For the age group of 9 to 11, the representative age is 10, and the median 6-minute walk distance in meters is 667.3. For the age group of 12 to 15, the representative age is 13.5, and the median 6-minute walk distance in meters is 701.1. And finally, for the age group of 16 to 18, the representative age is 17, and the median 6-minute walk distance in meters is 727.6. Looking at the data, it appears that the higher the age of someone, the longer their 6-minute walk in meters is. The median age is taken from the age group in the first column and put into the representative age column in the second column. Here is the least squares regression line of each age group's median 6-minute walk distance in meters. For the y value is the median 6-minute walk distance in meters. It starts at 0, but there is a break in the graph and starts back at 500 and is raised by 25 each time up until it reaches 750. For the x values, which is the age group, it starts at 0 to 3, then 3 to 5, 6 to 8, 9 to 11, 12 to 15, and 16 to 18. It appears that most of the data is close to the line, except for the one point right here. Now, to calculate the residuals, you must first have to enter in your values to the L1 and L2 in the Now, we must calculate the residual values. First, we have to enter in all of our data into the Stat button on our calculator. Once you have entered in all the values, go over to L3 and hit the Enter button. Next, go to the line reg feature on your calculator and enter it into the Y1 value. Next, go over to L3 on your stat and hit enter, and then hit second stat, and then hit 7 for residual. Hit enter and it will give you your residual values. Next, go to second y equals and go to your first plot and go all the way down to the Y list and put second L3 and hit enter and then graph it, and then you will get your residual values. Looking at the residual plot, there appears to be no unusual features.